dealing with polynomials. We are going to, it's the pre-assessment. We're going to multiply. We are going to add and subtract. So this first two problems are just your traditional monomial times a binomial. And we're going to use the distributive property that looks like this, distributing the 11 times to each of the terms inside the binomial. So we get 110x plus 77. We distribute that out. And remember, we want to put it in standard form. This is in standard form. Constant would always come last. 4 times 4x plus 4 times 5 gives us 16x plus 20. As they get more complex, I'll add some more detail, but right now we're just distributing and we're multiplying. These are simple. You can do mental math. You can, here we go. So now we have 11v times 12v plus 11v times negative 4. A couple things that we should be aware of here is our two terms inside the binomial are 12v and negative 4. That negative gets attached to the 4. And remember, we're distributing 11v. So that's why the 11v is positive. So we see the positive sign here, and we see the negative sign with the 4. Now when we multiply these two monomials, a monomial times a monomial, we're going to multiply their coefficients, which is 132, and then we multiply their variables. V times v is v squared minus 44v. And that is in standard form again. V squared is going to come before v. When we have putting them in order, we're going to put the variables in alphabetical order. And then if they tie with their alphabet like they do in this case, we're going to put the variable with the highest exponent. So we have 2m times 11m plus 2m times negative 9, which gives us 22m squared minus 18m. We have 9 times 6x plus 9 times 4, which gives us 54x plus 36. 10n times 12n plus 10n times negative 2. That's going to give us 120. That's a bad 120. 120n squared minus 20n. These cannot be combined because they are not like terms. Like terms have to have the same variable and same exponent. These have the same variable but not same exponent. So they are unlike term. So this is as far as we can combine. We're going to distribute 11 to 5x and 11 to 1, which gives us 55x plus 11. 7 times 3b plus 7 times 5 is 21b plus 35. 3 times 11x plus 3 times negative 4, 33x minus 12. Now we have a monomial times a trinomial, so we will just distribute it 3 times. We have 4a times 4a squared plus 4a times negative 3a plus 4a times negative 3. Trying to save space. That's 16a cubed, coefficient times coefficient. 4 times 4 is 16, and then we have variable times variable, which makes a to the third. Then we have minus 12a squared minus 12a. We are distributing a 4 to 9x squared and a 4 to 4x and a 4 to negative 6. That gives us 36x squared plus 16x minus 24. And you see the speed in which I'm doing these. You should be at this speed because you hopefully have done hundreds of these in order to prepare for the assessment. I continue to ask to please put in the time so you are not reacting, that when you see this problem like number 14, you know exactly how to attack it. You know exactly what you're writing, and you're just going through the motions. It's almost like you can do it with your eyes closed. So 9 times 12 is 108. R cubed times r squared is r to the 5th. 9 times negative 4 is negative 36. R to the 3rd times r is r to the 4th. 9 times 11 is 99. R to the 3rd, and it's in standard form because we have r to the 5th, r to the 4th, r to the 3rd. Standard form, descending order, biggest to smallest. 10k to the 3rd times 2k squared plus 10k to the 3rd times 9k plus 10k to the 3rd times 1. That's going to give me 20k to the 5th plus 90k to the 4th plus 10k to the 3rd. 3 times 6a squared plus 3 times 11a plus 3 times 6. 18a squared plus 33a plus 18. That's how fast you should roll through these. 12 times 6r squared plus 12 times 11r plus 12 times negative 9. It's only taking you longer because you're writing out this step. But 72r squared plus 132r minus 108. And you're just doing your times tables. That's the only thing that should be slowing you down. And you should know your times tables. So this is really good. Finding the speed and the efficiency of this. Making that a 3, that's an ugly 3. Negative 8 is just, doing all these is good for your times tables. So you can, that's a horrible k, there we go, minus 48k to the 3rd. 8n times 10n squared plus 8n times 8n plus 8n times negative 1. 80n to the 3rd plus 64n squared minus 8n. 8r times 4r squared plus 8r times negative 4r plus 8r times negative 10. That's going to give us 32r cubed minus 32r squared minus 80r. My handwriting is not so good today. Now we're binomials. So what we're going to do is, this is just double distribution. Some people call it FOIL. So we're going to take this first term and we're going to distribute it to each of the items in the other binomial. And then we're going to distribute, this is the double distribution component of it. We're going to take that second term and we're going to distribute it. I can't make it turn. Yes. And then we're going to distribute it to both of those terms. So it looks like this. 2x times 9x plus 2x times 7. That's the yellow portion. Smartboard dying. 2x that we distributed to the 9x and the 7. And then we are going to distribute the 6 to the 9x and the 6 to the 7. So that second piece is the 6 being distributed to each of the things inside the second binomial. So that's going to give us 18x squared plus 14x plus 54x plus 42. And this is where, knowing your times tables, we have like terms here. We've got 14x and 54x are like terms. And so we have 18x squared plus 68x plus 42. And that is our answer. We can't combine any of those. That's x squared is not like terms with x, so they can't be combined. This is going to look like 6n times 8n plus 6n times 12 minus 3 times 8n minus 3 times 12. So we're distributing that negative 3. Notice that we distribute the negative 3, so I have a negative 3 that is being distributed. So that's 48n squared plus 72n minus 24n minus 36. 48n squared plus 48n minus 36. There you go. How fun is that? 4r times 2r plus 4r times 2 minus 7 times 2r minus 7 times 2. Fit it in the space. 8r squared plus 8r minus 14r minus 14. Like terms here, 8r squared minus, what's that, 6r minus 14. 2n times 6n plus 2n times 3 minus 7 times 6n minus 7 times 3. 12n squared plus 6n minus 42n minus 21. 12n squared minus 36n minus 21. 12n times 6n plus 12n times negative 12 minus 3 times 6n minus 3 times negative 12. Ran out of space. That's going to be 72n squared minus 144n minus 18n plus 36. 72n squared minus 162n plus 36. Woo! That is a big middle term there. Yep, that's right. 4m times 2m plus 4m times negative 7 minus 7 times 2m minus 7 times negative 7. That's 8m squared minus 28m minus 14m plus 49. 8m squared minus 42m plus 49. V times 9v plus v times 2 minus 1 times 9v minus 1 times 2. 9v squared plus 2v minus 9v minus 2. 9v squared minus 7v minus 2. 7r times 9r plus 7r times negative 4 plus 10 times 9r plus 10 times negative 4. 63r squared minus 28r plus 90r minus 40. 63r squared plus 62r, all right, 6, 7, 8, yep, minus 40. That's good. That is correct. Woo, these are going to get big. 12r times 4r plus 12r times 12 minus 3 times 4r minus 3 times 12. Fit it. That's a horrible. There you go. 48r squared plus 144r, we've seen that, minus 12r minus 36. 48r squared plus 132r. 132r minus 36. Yeah, 2, 13, yep. 9n times 10n plus 9n times 7 plus 3 times 10n plus 3 times 7. 90n squared plus 63n plus 30n plus 21. 90n squared plus 93n plus 21. All right. Are we done? Oh, conjugates. When we see that we have conjugates which are identical but opposite signs, we know that the outside and inside, our outside, which is 7m, and our inside, which is negative 7m, are going to cancel. They're opposite of each other. So we're left with m squared minus 49. We're left with our first and our last. This is a binomial square, not conjugates. These are conjugates. This is a binomial square. Binomial square is always going to fit this template. You're going to square the first. You're going to square the last. And then you're going to multiply the first times the last. P times 8 is 8p, and then times 2. So that's going to be 8p doubled is 16p. Now, can you do p plus 8 quantity squared is p plus 8 times p plus 8? Absolutely. Can you do p times p plus p times 8 plus 8 times p plus 8 times 8? Sure. Can you do p squared plus 8p plus 8p plus 64? And you see why we double the 8p, because there's two of them. They're identical. Why are they identical? Because we're multiplying the same binomial times itself. So either way you want to do that, I'm going to multiply and double, which is 8n, and then I'm going to square my last. These are conjugates, so I'm going to multiply my first and my lasts. Much easier to do that. If we recognize the problem, it's a whole lot easier. 64m squared. 6 times 8 is 48, negative 48. Negative 48 doubled is negative 96m. And then we're going to square negative 6, which is positive 36. That's going to be a whole lot easier. 36b squared. 6b times 2 is 12b. Doubled is 24b. And then I'm going to square 2. These are conjugates, so 8a times 8a is going to be 64a squared. Negative 8 times 8 is negative 64. We're always going to have the difference of two squares. That's why it's conjugates. n squared minus 49 is going to be the easiest way to do this. 49x squared, 7x times 4 is 28x. Double it is 56x plus 4 squared is 16. That's the speed that you want to do it. All right, now we're going to slow back down and we're going to add and subtract polynomials. This is a trinomial minus this trinomial. So we must take this negative if we're going to subtract it, and we're going to distribute that negative 1 to each of those terms. So it's unaffected by the left one. 5n to the fourth minus 2n squared minus 8n. And now we're going to multiply that negative 1 times each of these three, which in a sense changes the sign of those three terms. So we had a positive 5n, now it's a negative 5n. We had a negative n squared, is a positive n squared now. Negative 8n is now positive 8n. And now I'm going to write them in descending order. I made a mistake. There you go. Thank you for not screaming at me. And the reason why I put them in standard form here is just so I can see the like terms. These are like terms because they have the same variable to the same exponent. That means we are going to combine their coefficients. 5 and negative 5 cancel out. We have these as like terms because they have the same variable to the same exponent. So we're going to combine their coefficients. Negative 2 and positive 1 leaves us with negative 1, and then we bring down the variable, n squared. And what do we notice about these two terms? They are also like terms, and their coefficients cancel. So my final answer is going to be negative n squared. So when we add, we're going to distribute out a positive 1, and anything times 1 is still going to give you that. So we just have 2v cubed minus 2v to the fourth plus 5 plus 2v to the fourth minus 4v to the third minus 1. Nothing changes in those. All we did was get rid of Chewbacca. So now I'm going to put them in order. 2v to the fourth plus 2v to the fourth plus 2v to the third minus 4v to the third plus 5 minus 1. Like terms, those cancel. Like terms, you get negative 2v to the third. And like terms, you get plus 4. So that is my answer. Keeping track, putting your answers in standard form. This is a negative, so 6x cubed minus 2x minus 4 are unaffected. Everything inside here is going to change, so you have negative 4 minus x minus 2x squared. I'm going to put them in order. 6x to the third minus 2x squared minus 2x minus x minus 4 minus 4. 6x to the third doesn't have a partner. Negative 2x squared doesn't have a partner. These are like terms. That becomes negative 3x. These are like terms. That becomes negative 8. There's my answer. Same thing. I have to distribute that negative into there, changing the signs. 5 minus 2r plus 7r to the third minus 2r to the third plus 6r to the fourth minus 7r. Let's put them in descending order. 6r to the fourth plus 7r to the third minus 2r to the third minus 2r minus 7r plus 5. No other constants. No pair for the 6r to the fourth. You get plus 5r to the third. You get minus 9r plus 5. You have to be proficient, and you have to be able to understand what is going on, how to add and subtract, what's going to be affected, what's not going to be affected, and so familiar that you can just rattle this stuff off, knowing your technique, that you're always going to put these in descending order. or what we call standard form. And knowing what things are going to stay the same, what things are not, what things are going to combine, what happens when things cancel, like the two n's. So negative 7n to the fourth plus 8n to the third plus 15n squared, and they cancel. Ooh, oh baby, 5x minus xy to the fourth. Probably not the best problem to not have any space. X squared y squared plus 3x plus xy to the fourth plus 7x to the fourth y to the fourth. So you're going to get 7x to the fourth y to the fourth. You're going to have minus 8x squared y squared. You have negative xy to the fourth. You have plus xy to the fourth. And then you have, I got to make this smaller. Sorry. Thanks for your patience. Let's grab all this. No, let's grab all this. Grab it. Let's make it smaller. Over here. Let's bring you guys out a little bit so we can see that. So it looks cleaner, shall we say. That's x to the fourth, y to the fourth. We are negative xy to the fourth, positive xy to the fourth. We are plus 5x plus 3x. X to the fourth, y to the fourth, negative 8x squared, y squared. These cancel, and you're left with 8x. That is standard form. X to the fourth, x to the second, x. The y's don't come into play until they are tied in their first variable. Oh my goodness. All right, I need smaller writing. 6v squared minus 2u to the third v squared plus 2u to the third v plus 8u to the third v squared minus 5v squared minus 7u to the third v. So I'm going to have u to the third. So negative 2u to the third v squared plus 8u to the third v squared. Then we have 2u to the third v. And we have negative 7u to the third v. And then we have 6v squared and negative 5v squared. That's standard form. U's are going to come before v's. And u to the third and u to the third, notice these are tied with u to the third, but this is v squared, this is v to the first. So not like terms, and then we put them in order. So we got these two are like terms, so we're going to combine their coefficients. That's 6u to the third v squared. These are like terms, so we're going to combine their coefficients, minus 5u to the third v. And then these are like terms, so it's plus v squared. And that would be my final answer. I'm going to make this smaller before we go on to the next problem. And that's in standard form too. Group. Got to make it even smaller. Yikes. Look how teeny that is. All right. It is what it is. Almost done. Now we got subtraction, so 7m to the fourth, n to the third, minus m to the fourth, minus 6. Now we're going to change all the signs. 6m to the fourth, n to the third, minus 3, plus 3m to the fourth. Let's put it in order. 7m to the fourth, n to the third, minus 6m to the fourth, n to the third, minus m to the fourth plus 3m to the fourth minus 6 minus 3. So notice that the m to the fourth n to the third came before m to the fourth alone. There's extra stuff. They both are m to the fourth, but the first two have an n to the third. So that'll come before. That's the order-wise. So we get m to the fourth n to the third plus 2m to the fourth minus 9. Yep. And again, these are easy because we do so many of them. We're constantly practicing. We are well aware of the tricks, the trades, and all the shenanigans that math books like to play on you. You're noticing I'm switching the signs of each of these terms because I'm distributing in that negative. So we get negative 4x to the third y squared minus 6x to the third y squared minus 6x squared minus 8x squared plus 7y minus 6y. That's negative 10x to the third y squared. The variables stay. It's just the coefficient that gets changed. And that is in standard form. And if I take the time to put them in standard form right now, it just saves me assurance. It assures that my answer is in standard form at the end. Last one, I think, yes. 5x plus 4x to the third y plus 8y to the third minus x squared y to the fourth minus 3y to the third plus minus 7x to the third y. All right, 4x to the third y minus 7x to the third y. Minus x squared y to the fourth plus 5x plus 8y to the third minus 3y to the third. That's there. So no, oh yeah, partners, yep. So negative 3x cubed y. No partner, negative x squared y to the fourth. No partner for 5x. And a partner for the y cubed. That's plus 5y cubed. And that is standard form. It's a horrible cube. There we go. X to the third, x to the second, x to the first, and then y cubed has no x variable. Boom. All right. Good luck with that. That's the orders. That's all that you should be doing. Good luck.